Right now, somewhere in the world, a developer just like you is staring at an error they can't solve. They're questioning everything, their intelligence, their choice of career, their entire future. And in the next 60 seconds, one of two things will happen. They'll close their laptop and tell themselves they're not cut out for this. Or they'll take a breath, open the documentation, and try again. The difference between these two developers isn't talent. It isn't education. It isn't luck. It's something far more powerful. It's a mental fortress, a psychological structure so solid that doubt can't penetrate it and failure can't collapse it. It is the difference between a career of mediocrity and a career of success. This audiobook will teach you how to build yours, because the code you write is only as strong as the mind that writes it. Chapter 1. The Lie. You've been told about talent. You've been lied to, not by one person, not by one institution, by an entire culture that worships the idea of natural talent. They told you that great developers are born, not made, that some people just get it and others don't, that if JavaScript doesn't click for you immediately, if you're still Googling syntax after 6 months, if you need Stack Overflow open in another tab just to get through a coding session, maybe you're not cut out for this. That's the lie, and it's destroying your potential. Listen carefully. Every senior engineer you admire, every architect, every tech lead, every developer whose GitHub profile makes you feel inadequate, was once exactly where you are right now. Confused by async/await, frustrated by merge conflicts, staring at documentation that might as well be written in hieroglyphics, ready to quit. The difference between them and the people who quit wasn't talent, not some genetic gift. The difference was this: they refused to believe that struggle means inadequacy. There are two developers staring at the same error message right now. The first one sees type error, cannot read property of undefined, and their internal narrative begins. I'm too stupid for this. Everyone else understands this. I should have studied harder. Maybe I'm not meant to be a developer. The second developer sees the exact same error and thinks, interesting. I referenced something before checking if it exists. Let me add a conditional. Let me console.log the object. Let me read this function again. Same error, same moment. Two completely different fortresses being built. The first developer is letting their emotions interpret technical feedback. The second developer is treating the error as what it actually is, data. That's the key. Frustration is not failure. Getting stuck on LeetCode medium problems is not incompetence. Spending 2 hours debugging a null pointer exception is not a sign you're in the wrong field. It's a sign your brain is adapting. Your brain rewires itself through repeated exposure to difficulty. That's not motivational fluff. It's measurable neuroscience. The myelin sheaths around your neurons thicken with practice. Pattern recognition pathways strengthen with repetition. What feels impossible today becomes automatic tomorrow, but only if you stay in the discomfort long enough. Intelligence is not something you're born with. It's built through repetition. But you don't believe that yet. You're still waiting. You're waiting for the moment when it all suddenly makes sense. The magical day when you wake up and understand pointers or big O notation, or why someone would ever use a linked list instead of an array. That day doesn't come. What comes instead is this. You struggle with object-oriented programming today. You struggle with it tomorrow. You watch 3 YouTube tutorials and still don't get inheritance. You build a class wrong 5 times. And then, one day, 6 months later, you're explaining polymorphism to someone else and you don't even remember when it stopped being hard. Let me show you what this looks like in practice. Marcus has been learning to code for 18 months. 4 boot camps completed. Hundreds of hours of YouTube tutorials consumed. 17 half-finished projects in his repositories. Marcus believes in talent. When he hits a roadblock, he assumes he's missing some foundational knowledge, so he starts another course. When his code doesn't work, he convinces himself he's not getting it, the way naturally talented developers would. Marcus is still looking for his first developer job. Priya started learning at the same time as Marcus. She only picked one language, Python, and built one project, a web scraper that evolved into a full data analysis tool. Her code was terrible at first. Functions that should have been 5 lines were 50. She didn't understand decorators for months. She used global variables everywhere, but she didn't restart. She refactored. She broke things. She Googled the same error messages dozens of times. She asked questions on Reddit and got downvoted for asking basic things. Priya got her first job 8 months ago. She's now mentoring junior developers. The difference wasn't talent, it was belief. Marcus believed talent was real, so every struggle confirmed he didn't have it. Priya believed competence was built, so every struggle confirmed she was building it. You don't see the thousands of hours senior devs spent confused. You don't see the projects they abandoned. You don't see the bugs that made them question their entire careers. You only see the polished pull request, the clean commits, the deployed application, and you compare it to your messy process. Stop doing that. The fortress isn't built by people who feel ready. It's built by people who code anyway. You're waiting to feel ready, waiting to feel confident, waiting for that internal voice that says, yes, now you're a real developer. That voice never comes. Not before you start, only after. Confidence doesn't create competence. Competence creates confidence. Every line of code you write, even the broken ones, even the spaghetti code that makes you cringe a month later, is proof that you're in the arena. Proof that you're building the fortress brick by brick. Stop waiting to feel ready and start building evidence. Evidence is the crud app you built that actually works, even if the code is ugly. Evidence is the segmentation fault you finally tracked down after 3 hours of debugging. Evidence is the rest. API endpoint you explained to a classmate, even though you barely understand HTTP. Evidence is the algorithm you implemented that has O of n squared complexity when it should be O of n log n, but it works and you shipped it. Evidence is not feelings. Feelings will tell you you're not ready. Feelings will tell you everyone else understands data structures better. Feelings will tell you to quit before you fail the technical interview. But sometimes, listen to this, your feelings are protecting you from real burnout, real exhaustion, real limits. You need to learn the difference between fear that's lying to you and fear that's warning you. But most of the time, feelings are just noise. And evidence is signal. Evidence is what you've actually deployed, debugged, and built. And every day that you code, the evidence grows. The evidence doesn't care how you feel. It doesn't care if you're confident. It just accumulates in your GitHub contributions graph. quietly, until one day you look back and realize you've built something real. The talent myth wants you focused on what you are. The fortress wants you focused on what you do. Here's your assignment, your test. For the next 7 days, you will implement the evidence protocol. 1. Write code for 1 hour minimum, not tutorials, not videos, actual code. 2. Document one specific thing you learned, not "I learned about arrays." Instead, "I learned that JavaScript arrays are zero-indexed and array.length returns undefined, not the last element." 3. Commit something to GitHub every single day, even if it's a comment, even if it's fixing a typo. The green square is evidence. 4. Rate your discomfort during each session from 1 to 10. Below 5, you're in tutorial hell, increase difficulty. Above 8, you're in panic mode, reduce scope but don't quit. The sweet spot is 6 to 7, uncomfortable but functional. 5. No browsing other people's GitHub profiles. 6. No scrolling LinkedIn for 20-year-old senior developer posts. 7. No watching. "I built this in 10 minutes" videos unless you're building it yourself. This is not motivational. This is tactical. You don't need talent. You need repetition. You need consistency. You need the discipline to keep pushing commits when the talent myth is screaming at you to quit. That's the first wall of your fortress, the rejection of the lie that you need to be special to succeed. You don't need to be special. You just need to show up. 7 days, 1 hour each, code, document, commit. Your fortress begins now. You've dismantled the talent myth. You understand now that struggling with sorting algorithms isn't evidence of inadequacy. It's neurological adaptation in real time. You have your protocol. You know what to do. But knowing what to do and actually doing it are separated by something more dangerous than ignorance, something that lives inside your own mind, something that whispers to you every time your code doesn't compile, every time you see that red error message, every time the imposter syndrome floods in. This enemy doesn't attack your intelligence. It attacks your ability to use it. And unless you learn to control it, everything you just learned is worthless. Chapter 2. Why your emotions are sabotaging your progress. You're staring at your screen right now. Maybe it's a runtime error you can't fix. Maybe it's a merge conflict you don't understand. Maybe it's a coding challenge that everyone says is easy, but feels impossible to you. And there's a voice in your head. It's loud. It's convincing. And it's telling you that you're not smart enough for this. That voice is not giving you information. It's giving you sabotage. Here's what no one tells you. Emotional reasoning is not logical reasoning. When you feel stupid because you don't understand recursion, that feeling is not evidence of your intelligence. It's evidence that you're learning something new. When panic floods your system during a technical interview, that panic is not proof you'll fail. It's your amygdala treating a whiteboard problem like a physical threat. Your emotions will often lie to you. They'll tell you that temporary confusion is permanent failure. They'll tell you that one bad coding session means you're in the wrong career. They'll tell you that the tightness in your chest when you see a 500-line error stack is a message from the universe that you should quit. It's not. It's just neurochemistry. And neurochemistry doesn't understand the difference between a failed deployment and a lion chasing you across the savannah. The Stoics understood this 2,000 years ago. Marcus Aurelius wrote, "You have power over your mind, not outside events. Realize this, and you will find strength." The fortress protects you from treating feelings as facts. Let me show you how this plays out in real time. There's a developer named Sarah. Talented, hard-working, completely at the mercy of her emotional state. When Sarah's code works on the first try, she feels like a genius. She's confident. She takes on ambitious features. She applies to senior positions. When Sarah encounters a bug she can't immediately solve, the entire structure collapses. She feels like a fraud. She questions her career choice. She scrolls LinkedIn looking at boot camp graduates who got jobs faster than her and spirals into comparison paralysis. Sarah's technical skill hasn't changed between these two moments, but her emotional interpretation of the same skill has created two completely different developers. One day she's unstoppable. The next day she's convinced she should switch to marketing. This is what happens when you let emotions run your decision-making system. There's another developer named James. Similar skill level to Sarah. Completely different operating system. James encounters a bug in production. His heart rate increases. His hands get sweaty. The panic starts to rise. But James has a protocol. He doesn't ask himself, "Am I smart enough to fix this?" He asks, "What's the input? What's the expected output? Where's the gap?" He doesn't interpret the bug as evidence of his incompetence. He treats it as data. The code broke. Code breaks. That's what code does. Now he debugs. James sets a timer for 10 minutes. If he doesn't make progress, he takes a break. He doesn't doom scroll. He doesn't spiral. He walks away, resets, comes back. In that 10-minute window, something often shifts. Not every time, but frequently enough. This is the difference between someone who codes with their emotions and someone who codes despite them. Pay attention to this. The 10-minute rule separates amateurs from professionals. When frustration hits, amateurs quit immediately. The error message feels personal. The confusion feels permanent. They close the laptop and tell themselves they'll come back to it later with fresh eyes. They rarely do. Or if they do, they bring the same emotional operating system and repeat the cycle. Professionals set a timer for 10 more minutes, not because they're more disciplined, not because they feel less frustration, because they've learned that breakthroughs tend to happen in the window, right after you want to quit. In that 10-minute window, you'll often find the typo you missed 17 times, the logic error that becomes obvious once you read it out loud, the Stack Overflow post that's right under your nose, the realization that you were passing a string when the function expected an integer. Not every time, but often enough that this single habit compounds into years of retained knowledge that quitters never accumulate. Here's the truth no one tells you. Your emotional state is a weather pattern, not a destination. Bad coding days don't mean you're a bad coder any more than rain means the sun is gone forever. You will have days where nothing compiles. Days where you can't remember basic syntax. Days where junior developers seem to grasp concepts faster than you. These days are not diagnostic. They're meteorological. The fortress teaches you to work in all conditions, knowing that clarity usually returns if you refuse to abandon the process. So, here's your choice. You can keep letting your emotions dictate your technical progress. You can keep treating every bug as a referendum on your intelligence. You can keep quitting right before the breakthrough because the discomfort feels unbearable. Or you can build a different system. For the next 14 days, you will implement a structured separation between feeling and action. Stage 1. The recognition phase. Days 1 to 3. Every time you feel the urge to quit during a coding session, pause. Name the emotion out loud. I'm feeling frustrated. I'm feeling stupid. I'm feeling overwhelmed. Write it down, time stamp it, rate it 1 to 10. Then code for 10 more minutes. After the 10 minutes, log whether you made progress or not. Stage 2. The pattern phase. Days 4 to 10. Review your emotion logs. You'll notice something. The emotions that felt permanent lasted 6 to 12 minutes on average. You'll see that most of the time, the 10-minute rule produced either a breakthrough or enough progress to continue. This is evidence, not motivation. Evidence that your feelings are often poor predictors of your capability. Stage 3. The automation phase. Days 11 to 14. Now you don't need to write it down. Frustration hits. You recognize it. You acknowledge it. This is the feeling. It's not truth. Timer starts now. 10 minutes. Every time. This becomes your default response to emotional interference. The debug ritual. When you encounter a problem that triggers emotional spiral, 1. Externalize it. Rubber duck debugging exists because explaining the problem out loud to an inanimate object forces you out of emotional reasoning and into logical sequencing. 2. Reduce scope. You're trying to build an entire authentication system and spiraling. Strip it down. Can you make one endpoint work? Can you hash one password? Can you validate one token? Smaller problems, smaller emotions. 3. Binary search your panic. Just like binary search and algorithms, divide the problem in half. Which half contains the bug? Focus there. Cut the problem space. Cut the emotional load. Let me tell you what happens when you master this. You'll be in a technical interview. The interviewer will give you a problem you've never seen before. The panic will start to rise. That familiar tightness in your chest, the voice saying, "You should know this." But you won't spiral. You'll recognize it. You'll name it. You'll set your internal timer. And while the other candidate is freezing, paralyzed by the emotion, you'll be thinking out loud, breaking the problem down, treating it like data instead of judgment. You won't always get the answer, but you'll get further than someone with better technical skills and worse emotional infrastructure. Here's the paradox. When you stop treating your emotions as absolute truth, they lose their power over you. And when they lose their power over you, they quiet down. Not gone, just manageable. The irony is this. The developers who seem naturally calm under pressure aren't calm. They're just practiced at not obeying the panic. But understand this. Success brings its own emotional traps. You'll fix the bug that's been breaking production for weeks. You'll feel invincible, and that feeling will make you sloppy. You'll skip writing tests. You'll deploy without reviewing. You'll assume you're too good to make mistakes, and you'll break something worse. The fortress doesn't just protect you from negative emotions. It protects you from positive ones, too. The challenge. Right now. Today. Find a coding problem that frustrates you. Set a timer for 10 minutes. Code through the discomfort. Log what happened. Do it again tomorrow. And the next day. This is how the second wall of your fortress gets built. The ability to operate when your emotions are screaming at you to stop. You've built emotional firewall protocols. You understand now that feelings are weather, not prophecy. You know that the 10-minute rule is the difference between those who learn and those who quit. But here's what you don't know yet. Your emotions aren't the only sabotage system running in the background. There's another force actively destroying your progress. It's more insidious because it doesn't feel like sabotage. It feels like research. It feels like motivation. It feels like you're being productive. You're not. You're feeding a bug that grows stronger every time you check your phone. Let's debug it. Chapter 3. The Hidden Cost of Comparison. You know what you did this morning. You opened LinkedIn, or GitHub, or Twitter, or some coding Discord server. And within 3 minutes, you saw someone younger than you who's already a senior developer. Someone who built in 2 weeks what you've been struggling with for 2 months. Someone who got hired at a FANG company straight out of boot camp while you can't even get past the automated coding assessment. And something inside you broke. Not dramatically, not all at once, just a quiet collapse. A small voice that whispered, "Maybe I'm too late. Maybe I'm not good enough. Maybe I should have started earlier." That voice is destroying you. Here's what you need to understand. Every minute spent comparing is a minute stolen from building. When you scroll through GitHub looking at repositories that make your projects feel inadequate, you're not researching, you're not learning, you're not gathering motivation, you're self-sabotaging. And you've been doing it so long you don't even recognize it as sabotage anymore. You think it's staying informed. You think it's seeing what's possible. You think it's learning from others. It's none of those things. It's comparison. And comparison is poison. Theodore Roosevelt said it a century ago. Comparison is the thief of joy. But it's worse than that for developers. Comparison isn't just stealing your joy, it's stealing your time, your focus, your momentum. Your belief that you can build anything worth building. Listen closely. Those developers had bad code once too. The architect whose TypeScript looks flawless, their first JavaScript looked like yours. The engineer whose system design is elegant, their first database schema was a mess of circular dependencies and N+1 queries. You're comparing your Chapter 1 to someone else's Chapter 20, and it's destroying your momentum. Let me show you how this plays out. There's a developer named Alex, 23 years old, learned Python 2 years ago. Decent skills, solid projects, could get a junior position if he applied. But Alex doesn't apply. Every morning, Alex opens LinkedIn. He sees posts from developers his age who are already senior engineers. He sees boot camp graduates landing $150,000 jobs. He sees teenagers building startups. Alex tells himself he's staying current with the market. But what he's actually doing is building a mental database of evidence that he's behind. By noon, Alex has convinced himself he needs to learn Rust, or Go, or whatever the trending language is that week, because if he doesn't, he'll fall further behind. So Alex starts a new tutorial, gets halfway through, sees someone on Twitter who's already shipping production Rust applications, feels inadequate again, abandons the tutorial. 2 years in, Alex has learned 12 frameworks and shipped 0 real projects. This is what comparison does. It creates motion without progress. There's another developer named Maya, same age as Alex, similar starting point. But Maya made a different choice 6 months ago. She deleted LinkedIn from her phone, muted every coding influencer on Twitter, left every Discord server except one small community where people actually help each other debug, not flex their accomplishments. Maya stopped researching what she should know and started building what she wanted to know. She picked Flask, built a terrible blog application, refactored it, added authentication, broke it, fixed it, deployed it. It's ugly. The code is messy, but it's live. Then she built a second project. Better code this time. Then a third. 6 months later, Maya has a portfolio. Alex has opinions about which framework is best. The difference isn't talent, it's attention. Maya's attention went into her code. Alex's attention went into everyone else's code. Pay attention to this. Comparison creates a fixed timeline that doesn't exist. You tell yourself you should already know Docker because other people your age do. You should understand system design because that's what senior developers know. You should have contributed to open source by now because everyone says that's important, but there is no cosmic schedule. There is no deadline for competence. There is no universal syllabus that says, by age 24, you must understand microservices architecture. The only race that matters is against the person you were yesterday. Did you know more today than you knew yesterday? Did you write better code this week than last week? Did you solve a problem this month that you couldn't solve last month? That's the only measurement that matters. Everything else is noise. Here's the truth no one tells you. The people you're comparing yourself to aren't thinking about you at all. The senior developer whose LinkedIn post made you feel inadequate, they're not measuring themselves against you. They're measuring themselves against where they want to be. The bootcamp graduate who got hired faster than you, they're too busy onboarding and learning the code base to care about your timeline. The developer whose GitHub contributions graph is solid green, they're not tracking who's behind them. They're tracking what they're building next. You're in a race that only exists in your head. So here's your choice. You can keep feeding the comparison machine. You can keep scrolling. You can keep collecting evidence that you're not enough, not fast enough, not good enough. Or you can build a fortress with no windows facing outward. Understand this. Inside your mental fortress, there is only you, your code, and your progress. What others are doing is irrelevant data. It doesn't affect your learning curve. It doesn't change what you need to do today. It doesn't make your code compile faster or slower. Build your walls thick enough that external noise can't penetrate, because the moment you let comparison in, doubt follows immediately behind it. The Comparison Blackout Protocol. For the next 30 days, you will implement strategic isolation from all comparison triggers. Phase 1. Information Quarantine. Days 1 to 7. Identify your poison. Where do you go to feel inadequate? LinkedIn, GitHub trending, Twitter tech accounts, Reddit's r/CSS career questions. Write them down. All of them. Delete the apps from your phone. Block the websites during work hours using browser extensions like Cold Turkey or Freedom. You still need technical information, but you'll get it differently. Subscribe to documentation sites, MDN, official framework docs, language specifications. Join one, and only one, small community focused on helping, not flexing. Replace scrolling with reading, technical books, deep dive blog posts, actual documentation. Phase 2, evidence accumulation, days 8 to 21. The daily progress log. Every evening, write down 3 things you learned or built that day. Not, I learned React. Instead, I learned how use effect cleanup functions prevent memory leaks. Not, I worked on my project. Instead, I implemented JWT token refresh logic and handled edge cases for expired sessions. This is your new feed, your progress. No one else's. The weekly wins document. Every Sunday, review your daily logs. Write a summary of what you shipped, debugged, or understood this week. Track only your trajectory. Ignore everyone else's. Phase 3, competitive redirection, days 22 to 30. Here's the secret. You don't eliminate the competitive drive. You redirect it. The Ghost Race Protocol. You're not racing other developers. You're racing past versions of yourself. Could last month's you solve today's problem? If yes, you're stagnating. If no, you're growing. Could last week's you write code this clean? If yes, refactor it. If no, you're evolving. The asymmetric advantage. While they're comparing, you're building. While they're switching frameworks to chase trends, you're mastering one. While they're curating their LinkedIn presence, you're debugging production issues. This is asymmetric warfare. They don't even know the battle is happening. Let me tell you what happens when you master this. 3 months from now, someone will ask what you've been working on, and you'll show them something real. Not perfect, not production ready for a Fortune 500 company, but real. A functioning application, a solved problem, a contribution to an open source project, evidence. And they'll ask, how did you find time to build all this? You won't tell them the truth. The truth is, you found time by stopping the comparison loop. You reclaimed the hours they're still spending scrolling. You redirected the mental energy they're still wasting on feeling inadequate. But here's the paradox, and this is critical. The moment you stop comparing yourself to others, they'll start comparing themselves to you. When you're quietly building while they're loudly performing, you create a gap. Not intentionally, just inevitably. And one day you'll open LinkedIn because you're human and you'll check eventually. And you'll see someone asking how you got so good so fast. And you'll realize they think you have talent. They think you're naturally gifted. They think you had some advantage they didn't have. They don't know the truth. The truth is you just stopped watching them and started building. But here's the warning. Success will tempt you to break the blackout. You'll want to post your wins. You'll want validation. You'll want everyone who doubted you to see what you've built. Resist. The fortress has no windows facing outward for a reason. Once you start performing for an audience, you stop building for yourself. And the moment you start optimizing for external validation, comparison creeps back in. The challenge. Right now, today, before you finish this chapter, delete one app, block one website, leave one community that makes you feel behind. Tomorrow, start your daily progress log. 3 things you learned. Written down. No comparison. Just evidence. Do this for 30 days. This is the 3rd wall of your fortress, the ability to build in silence while the world performs in noise. You've built the comparison blackout. You understand now that other people's timelines are irrelevant to your trajectory. You know that the only race that matters is against yesterday's version of yourself. But here's what you haven't faced yet. What happens when the comparison stops, when the noise fades, when the distraction disappears? What's left is you, alone, with your code, with your doubts, with no external metric to tell you if you're doing well. And in that silence, you'll encounter the most dangerous enemy you've faced yet. Not imposter syndrome, not comparison, not emotional sabotage. Something worse. The enemy that shows up when there's no one left to blame, no excuses left to make, and nowhere left to hide from the simple, brutal question. Are you actually building anything, or are you just going through the motions? Chapter 4. Failure is information, not identity. You broke production last week. Or maybe it wasn't production. Maybe it was just your local environment. Maybe it was a coding challenge you thought would take 20 minutes but consumed 3 hours, and you still didn't solve it. Maybe it was a pull request that got rejected with comments like, "This won't scale," and "Did you even test this?" And you felt it, that crushing weight, not just disappointment, something deeper, shame. You felt like the failure revealed something true about you, something you'd been hiding, proof that you're not actually cut out for this, evidence that everyone else belongs here and you're just pretending. Listen to me. You are not your broken code. When your program crashes, when your algorithm fails, when your deployment breaks production, these are events, not reflections of your worth. The fortress separates what happened from who you are. Failed code is debugging data. Nothing more, nothing less. But you've been conditioned to treat it as identity confirmation. Society taught you that failure means you're a failure. School taught you that wrong answers mean you're wrong. Every rejection email, every failed interview, every bug that took hours to fix has been building a case in your mind that maybe you're just not good enough. That case is fiction. Nietzsche said, "That which does not kill us makes us stronger." But he was wrong about one thing. Suffering doesn't automatically make you stronger. Only examined suffering makes you stronger. Only failure that you extract lessons from becomes strength. Everything else is just pain. The fortress doesn't prevent failure. It weaponizes it. Let me show you 2 developers facing the exact same failure. There's a developer named Chris, mid-level skills, decent understanding of JavaScript, gets assigned a feature, implement real-time notifications using WebSockets. Chris has never worked with WebSockets before. He reads the documentation, watches tutorials, writes the code, deploys to staging. It doesn't work. The connections drop randomly, messages arrive out of order. Under load, the whole thing crashes. Chris's internal dialogue. "I'm terrible at this. Real developers would have gotten this right. I should have known about connection pooling. I should have anticipated race conditions. Everyone's going to see this code review and know I'm a fraud." Chris spends the next 3 days rewriting everything from scratch. Not because the first attempt was fundamentally wrong, because the failure felt like a verdict on his competence. He's still working on it 2 weeks later, paralyzed, afraid to push code that might fail again. There's another developer named Jordan. Same skill level, same feature assignment, same WebSocket failure. But Jordan's internal dialogue is different. Interesting. WebSockets dropped under load. That means my connection handling isn't accounting for network instability. Let me check how I'm managing reconnection logic. Let me add heartbeat pings. Let me test what happens when 100 concurrent users connect. Jordan treats the failure as a debugging session, not a referendum, not evidence of inadequacy, just data. 3 days later, Jordan has a working solution, not perfect, but functional, shipped. The difference isn't skill, it's interpretation. Chris treated failure as identity. I failed, therefore I am a failure. Jordan treated failure as information. This failed, therefore I need different information. This is critical. Here's the truth. The most valuable lessons are hidden inside your mistakes. Every senior developer you admire has a graveyard of failed projects. AWS outages they caused, databases they corrupted, algorithms they optimized that made performance worse, architectural decisions they regret so deeply they wake up at 3 a.m. remembering them years later. Those failures weren't obstacles to their success. They were the foundation of it. You're not behind because you're failing. You're behind if you're not failing enough. Junior developers who spend 3 weeks making their authentication system perfect. Before testing it, learn slower than developers who implement basic login, test it, watch it break, fix the session handling, break it again, add password hashing, realize they're storing tokens wrong, refactor, test again. One approach feels safe, the other feels chaotic. But chaos with feedback beats perfection without deployment. Reframe failure as feedback velocity. The faster you fail, the faster you learn. The fortress doesn't prevent failure, it weaponizes it. Every error message becomes strategic intelligence. Every stack trace becomes a map of what you don't understand yet. So here's your choice. You can keep treating failure as identity confirmation. You can keep letting broken code convince you that you're broken. You can keep hiding your mistakes, rewriting everything in private, never shipping until it's perfect. Or you can build a failure processing system, the failure autopsy protocol. For the next 21 days, you will systematically extract intelligence from every failure. Phase 1. The immediate capture. Days 1 to 7. When something breaks, stop the identity spiral immediately. The moment you think, "I'm so stupid," or "I'll never be good at this," interrupt it. Say out loud, "The code failed. I did not fail. What information does this give me?" Document the failure forensically. What was supposed to happen? What actually happened? What was the error message? Copy it exactly. Don't paraphrase. What was the input that triggered it? What assumptions did I make that were wrong? Implement the 5 why debug. 1. Why did it fail? Because the API returned null. 2. Why did the API return null? Because the request timed out. 3. Why did it time out? Because I didn't set a timeout limit. 4. Why didn't I set one? Because I didn't know I needed to. 5. Why didn't I know? Because I didn't read about error handling in async requests. Root cause identified. Lesson extracted. Phase 2. The pattern recognition. Days 8 to 14. Create your failure library. Start a document titled Bugs I've Fixed and What They Taught Me. Every failure gets an entry. Date. What broke. Root cause. What I learned. How to prevent it next time. Weekly pattern analysis. Every Sunday, review your failures for the week. Look for patterns. Do you always forget to validate input? Do you consistently underestimate edge cases? Do you skip error handling to ship faster? These patterns are not character flaws. They're curriculum. Your mistakes are telling you what to study next. Phase 3. The weaponization. Days 15 to 21. Deliberate failure injection. This is advanced, and it requires safety protocols. In your test environments, local projects, or staging, never production, start breaking things on purpose. Build a feature, then ask, what happens if the database is slow? What if the user sends malformed JSON? What if 2 requests hit this endpoint simultaneously? Test those scenarios in safe environments. Watch them break. Fix them before they reach production. The public failure log. This is optional but powerful. Share 1 failure per week in a blog post, tweet, or dev community. Format. I broke X. Here's why. Here's what I learned. 2 things happen. 1. You stop hiding failures. 2. Other developers realize they're not alone. The failure quota. Set a minimum number of meaningful failures per week in safe environments. Not typos. Real architectural mistakes, logic errors, performance issues discovered through testing. If you haven't broken anything this week in development, you're probably not pushing your limits enough. Let me tell you what happens when you master this. 6 months from now, you'll encounter a catastrophic bug in production, something that takes the service down, something that affects real users, something that 2 years ago would have sent you into a shame spiral for days. But you won't spiral. You'll treat it like a debugging session. You'll check the logs. You'll trace the request. You'll find the race condition or the memory leak or the infinite loop. You'll fix it. You'll write a post-mortem. You'll add monitoring so it doesn't happen again. And while everyone around you is panicking, you'll be calm. Not because you don't care, because you've built the infrastructure to turn failure into intelligence. Here's the paradox. Developers who fear failure often make more critical mistakes, because fear makes you rush. Fear makes you skip tests. Fear makes you hide problems until they're catastrophic. Developers who treat failure as data tend to make fewer critical mistakes in production, because they're breaking things early, in controlled environments, learning from small failures before they become big ones. But here's the warning. This path will make you comfortable with failure. Maybe too comfortable. You'll start to think that shipping broken code is acceptable, that move fast and break things means you don't need to care about quality. That failure is always a learning opportunity, so it doesn't matter if you're sloppy. Wrong. The fortress weaponizes failure, but it doesn't worship it. There's a difference between strategic failure, breaking things to learn in safe environments, and negligent failure, breaking things because you didn't care enough to check. Learn the difference. Fast. The challenge. Today. Right now. Find something you built that you're afraid to test because it might break. Test it in a safe environment. Watch it break. Document what broke and why. Fix it. Do it again tomorrow. This is the fourth wall of your fortress, the ability to extract intelligence from destruction instead of letting destruction extract your confidence. You've built the failure autopsy system. You understand now that broken code doesn't mean you're broken. It means you have new information. You know that controlled failure in safe environments accelerates learning faster than perfectionism. But here's what you haven't confronted yet. All of this, the talent rejection, the emotional firewall, the comparison blackout, the failure weaponization, it requires something most people don't have. And this isn't something you're born with. It's something you build. Brick by brick. Let's build it. Right now, somewhere in the world, a developer just like you is about to quit. Not because the code is too hard, not because they're not smart enough, but because they're waiting to feel ready, waiting to feel motivated, waiting for that magical day when coding feels easy and everything finally clicks. That day doesn't exist. And while they're waiting, another developer, with the exact same skill level, the exact same resources, the exact same 24 hours, is building. Not because they feel like it, because they have a system that makes feelings irrelevant. Here's what nobody tells you about 2026. The market is flooded. Bootcamp grads with polished portfolios. AI tools that write code faster than you can think. 10,000 applicants for every junior position. The developers who make it aren't the ones with the most talent. They're the ones who showed up every single day when talent didn't matter, when motivation died, when the LinkedIn posts stopped getting likes, when no one was watching. They built a fortress, and you're about to learn how to build yours. In the next hour, we're going to dismantle 3 lies that are destroying your progress. Lie number 1. You need to feel inspired to write code. Truth, you need a 1-hour ritual, non-negotiable, no exceptions. The kind of system that makes motivation irrelevant because discipline is already running in production. Lie number 2. Posting your journey keeps you accountable. Truth, broadcasting your progress is draining the energy you need to actually build. The fortress is constructed in private. The results speak in public. Lie number 3. Your negative thoughts are just who you are. Truth, your thoughts are buggy code. I'm not smart enough is a runtime error that's been crashing your progress for years. Today, we're debugging your mind like you debug your applications, with tests, evidence, and zero tolerance for unvalidated assumptions. If you're tired of watching everyone else ship while you're stuck in tutorial hell, if you're done with the dopamine hits from LinkedIn, likes that don't translate to actual skills, if you're ready to stop performing progress and start building proof, you have to do this. This is your protocol. Let's build your mind fortress. Chapter 5. Discipline beats motivation. Every single time. It's 8 p.m. on a Tuesday. You've been at work all day, or classes, or both. You're exhausted. Your brain feels like static. Every part of you wants to collapse into bed, scroll your phone, watch something on YouTube Shorts. But you told yourself you'd code today. You told yourself you'd work on that side project, solve that algorithm problem, read that documentation, build that feature. And now, in this moment, You're negotiating with yourself. I'll do it tomorrow when I'm fresh. I've already worked hard today. I deserve a break. I'm too tired to write good code anyway, so what's the point? And you know, deep down you know, that if you give in tonight, you'll give in tomorrow, and the next day, and the day after that. This is the moment. Right here. This is where most developers lose, not because they lack talent, not because they don't understand the concepts, because they're waiting for motivation to show up and save them. It won't. Here's what you need to understand. Motivation is a spark. Discipline is a system. Motivation got you to start learning to code. It will not get you through data structures. It will not carry you through system design. It will not sustain you when you're debugging at midnight because production is down and you can't figure out why the authentication middleware is rejecting valid tokens. Discipline is showing up when every part of you wants to quit. The Stoics knew this. Marcus Aurelius wrote, "At dawn, when you have trouble getting out of bed, tell yourself, I have to go to work as a human being. What do I have to complain of if I'm going to do what I was born for?" You weren't born to code, but you chose to code. And choice without commitment is just daydreaming. The fortress is not built by people who feel inspired. It's built by people who show up anyway. Let me tell you about two developers with the same goal. Land a software engineering job in 6 months. There's a developer named Tyler, smart, capable, full of enthusiasm. When Tyler feels motivated, he's unstoppable. He'll code for 6 hours straight. He'll solve 5 LeetCode problems in one sitting. He'll refactor an entire project because he's in the zone. But motivation is weather. It comes and goes. On Monday, Tyler watches a YouTube video about someone who went from boot camp to Google in 9 months. Fired up, inspired. He opens LeetCode and crushes 3 medium problems. On Tuesday, Tyler's tired from work. He scrolls Reddit instead. Tells himself he'll restart fresh on Wednesday. On Wednesday, he's motivated again, builds half of a React component for his portfolio project. On Thursday, he's not feeling it. The component is harder than he thought. He'll finish it this weekend. By Friday, he's watching tutorials about Next.js because someone said React is old now. 6 months later, Tyler has started 12 projects, finished 0, solved maybe 40 LeetCode problems total, and still doesn't feel ready to apply for jobs. Tyler didn't fail because he wasn't smart enough. He failed because he treated discipline like a feeling instead of a system. There's another developer named Rachel. Same starting point as Tyler, same 6-month goal. But Rachel doesn't wait for motivation. Rachel has a protocol. 1 hour of coding. Every single day. No exceptions. Some days she feels inspired. Most days she doesn't. It doesn't matter. She sets a timer. She opens her IDE. She works. On good days, she solves 3 problems. On bad days, she solves 1 and barely understands it. On terrible days, she reads documentation for an hour and writes 20 lines of messy code. But she shows up. Every single day. 1 hour, minimum, non-negotiable. 6 months later, Rachel has solved 180 LeetCode problems. She's built and deployed 3 portfolio projects. She's contributed to 2 open-source repositories. She's applied to 30 companies and has 4 offers. The difference between Tyler and Rachel isn't talent, it's discipline. Pay attention to this. Motivation is dopamine-driven. Discipline is protocol-driven. Your brain releases dopamine when you feel excited about something. That's motivation. It feels good. It makes coding feel easy. But dopamine is unreliable. It spikes when you watch a day in the life of a software engineer video. It crashes when you're stuck on a bug for 3 hours. Discipline doesn't care about dopamine. Discipline is a contract you made with yourself, and you honor contracts even when you don't feel like it. Understand this. 1 hour minimum. No exceptions. Not code when you feel like it. Not try to code most days. Not I'll make up for it on the weekend. 1 hour of focused coding work. Every single day. Regardless of how you feel. Not when you're inspired. Not when it's convenient. Every day. This is critical. Here's why. This non-negotiable commitment creates momentum that motivation could never sustain. On day 1, 1 hour feels hard. On day 7, it's routine. On day 30, you feel wrong if you don't code. On day 90, people start asking how you learned so much so fast. The truth is, you didn't learn fast. You learned consistently. And consistency over time beats intensity every single time. So, here's your choice. You can keep waiting for motivation. You can keep coding only when you feel like it. You can keep telling yourself that discipline will come naturally once you find the right project or the right framework. Or you can build the discipline protocol that makes motivation irrelevant. This is not optional. This is the foundation of everything else you've built. Phase 1. The ritual installation. Days 1 to 14. The 1 hour block. Pick the same time every day. Morning before work or school, evening after dinner, late night when everyone's asleep. It doesn't matter when. It matters that it's consistent. Set a timer for 1 hour. During this 1 hour, code, debug, read documentation, solve problems. No tutorials unless you're typing along. No passive learning. Active work only. No phone, no Discord, no Slack, no email. Just you and the code. The motivation bypass. You will not feel like doing this most days. Good. When the time comes, don't ask yourself if you want to code. Just open your IDE and start. The first 10 minutes are always the hardest. After that, momentum takes over. The minimum viable progress. Some days you'll write 90 lines. Some days you'll write 10. Both count. Both honor the contract. The goal is not volume. The goal is showing up. Phase 2. The compound effect. Days 15 to 30. Start the daily micro habit. 1 LeetCode code problem. Every day, minimum. Easy problems are fine. The point is consistency, not difficulty. 30 days later, you've solved 30 problems most developers never attempt. 1 year later, you're in a different category entirely. Track your streak. Use a calendar. Mark every day you honor the 1 hour commitment. After day 7, you won't want to break the chain. After day 14, the streak becomes its own motivation. Phase 3. The discipline stress test. Days 31 to 60. You will have terrible days. Days when you're sick, days when you're heartbroken, days when production breaks and you spend 12 hours fixing it. On those days, the 1 hour rule becomes the 30-minute rule, or the 15-minute rule, but it never becomes the 0-minute rule. A Adjust the volume. Never break the pattern. If you can't code for 1 hour, read documentation for 30 minutes. If you can't read documentation, watch a technical conference talk. If you can't do that, open your IDE and write one function signature. Never zero. Never. Find one person, a classmate, a Discord friend, a mentor, who also commits to the 1 hour minimum. Check in daily. No judgment. Just, did you do the 1 hour? On days when you don't want to, knowing someone will ask is often enough. Let me tell you what happens when you master this. 1 year from now, you'll look back at your GitHub contributions graph. It will be solid green. Not because you're obsessed, not because you have no life, because you honored a contract. You'll have solved hundreds of problems, built multiple projects, contributed to code bases you once thought were too advanced for you. And people will ask, how did you get so good? You won't tell them about discipline. You'll probably say something about enjoying coding or finding good online courses. But the truth is simpler but harder. You showed up every single day when you didn't want to. Here's the paradox. When you stop relying on motivation, you become more motivated. When coding is a discipline, something you do regardless of how you feel, the pressure to feel inspired disappears. And ironically, once that pressure disappears, inspiration shows up more often. You'll have days where you sit down for your 1 hour block, and suddenly it's 4 hours later, and you've entered flow state without even noticing. But those days only come because you also showed up on the days when flow state never arrived. But here's the warning. Discipline can become its own trap. You'll start to believe that you're only valuable when you're productive, that rest is weakness, that if you're not coding, you're falling behind. Wrong. The fortress has discipline as its foundation, but discipline without rest becomes self-destruction. Learn to distinguish between discipline, showing up consistently, and burnout, showing up compulsively, even when your body and mind are screaming for recovery. Discipline means coding 1 hour even when you're tired. Discipline does not mean coding 1 hour when you're sick, burnt out, or experiencing a mental health crisis. Know the difference. The challenge. Right now, today, set your timer for 1 hour. Code. Do it again tomorrow, and the next day, for 60 days straight. This is the 5th wall of your fortress, the ability to build when motivation has abandoned you, the ability to show up when inspiration is nowhere to be found, the ability to honor commitments to yourself even when no one's watching. You've built the discipline protocol. You understand now that motivation is weather and discipline is architecture. You know that the 1 hour minimum is not negotiable. You know that small disciplines compound into insurmountable advantages over time. But here's what you haven't confronted yet. You're building all of this in private, in your room, at your desk, alone. And you've started to wonder, is this isolation making you stronger, or is it just making you lonely? Your friends are out there, living, socializing, building relationships, and you're here, writing code, solving problems, building a future they can't see yet. And sometimes, late at night, when the code won't work and the loneliness feels heavy, you wonder if you're making a mistake. You're not. Let me show you why. Chapter 6. The power of working in silence. There are two developers starting their learning journey today. Both of them just decided to learn React. Both of them opened the documentation. Both of them created their first component. The first developer immediately takes a screenshot, posts it to Twitter. Day 1 of learning React. Let's go. Hashtag 100 days of code, hashtag learn to code. They post it to LinkedIn. They share it in 3 Discord servers. They update their bio. Currently learning React. 30 people like it. 5 people comment, keep going. One person says, React is easy. Wait until you try next.js. That developer feels good, validated, seen. They've announced their journey. They've made it public. They've committed to the world. The second developer finishes their first component. They don't post anything. They don't announce anything. They just save the file, commit it to a private repository, and move on to the next lesson. 6 months later, the first developer is still posting about day 87 of learning React with the same beginner-level code. The second developer has built and deployed 3 full-stack applications, contributed to 2 open-source React libraries, and just accepted a job offer where React is the primary framework. The difference isn't talent, it isn't dedication, it isn't even time invested. The difference is this. One developer is spending their energy performing the work. The other is spending their energy doing the work. And you need to understand something right now, something that will change everything about how you approach learning to code. Broadcasting your journey is draining your energy. Every post about what you're learning, every update about your progress, every just shipped my first API endpoint, celebration, every plea for validation disguised as sharing your wins. All of it, every single bit of it, is energy that should be going into the work itself. You think you're building in public. You think you're staying accountable. You think you're inspiring others or documenting your journey. You're not. You're performing. And performance requires energy. Energy that you don't have infinite amounts of. Energy that once spent on the performance isn't available for the actual work. Listen closely. The fortress is built in private. Results are revealed in public. This is not a suggestion. This is not a personality preference. This is a tactical decision that separates developers who actually build things from developers who build personal brands about wanting to build things. Let me show you exactly how this plays out. There's a developer named Daniel, 22 years old, smart, motivated, active on every platform. Daniel starts learning Node.js. Day 1, he posts about it. Starting my back-end journey, Node.js, here I come. 50 likes, instant dopamine hit. Day 3, he builds a simple Express server, posts the code snippet to Twitter. Just built my first API endpoint. Who remembers their first time? Comments roll in. Great job. Keep going. Try adding middleware next. Daniel feels accomplished. He's done something. He's been recognized for it. His brain releases more dopamine. The validation circuit activates. But here's what's actually happening neurologically. Daniel's brain is treating the social validation as the reward, not the learning, not the competence, the validation. So when Daniel sits down the next day to learn about authentication, his brain isn't motivated by mastering authentication. It's motivated by the next post, the next validation hit, the next round of likes and comments. 3 months in, Daniel has posted 90 times about learning Node.js. He has 2,000 followers. People tag him as inspiration. He still can't build a complete, authenticated REST API from scratch without following a tutorial. There's another developer named Elena, same age as Daniel, started learning Node.js the same week. Elena doesn't post about it at all. She builds her first Express server. No announcement. She implements JWT authentication. No celebration post. She builds a complete REST API with user management, learns Docker, deploys it to AWS, breaks it, fixes it, refactors it. Silence. 3 months in, Elena has 0 posts about Node.js. She has 47 followers, most of whom are her college classmates. She also has a fully functional, production-ready back-end application in her portfolio. And when she shows it to potential employers, they don't care about her follower count. They care that the code works. Pay attention to this. The difference between Daniel and Elena isn't that Elena is more talented. It's that Elena never confused the performance of learning with the actual learning. Here's the psychological trap. Silence eliminates the performance anxiety. When no one is watching, you're free to be bad at something, free to write terrible code, free to ask stupid questions on Stack Overflow, free to fail for 3 hours trying to figure out why your middleware isn't executing in the right order, free to build something that doesn't work, throw it away, and start over. This psychological safety accelerates learning exponentially. When you're performing, you're optimizing for appearances. You're asking yourself, will this make me look competent? Will people think I know what I'm doing? Is this impressive enough to post? When you're working in silence, you're optimizing for growth. You're asking yourself, does this work? Do I understand why? What happens if I change this? What don't I know yet? One question produces content, the other produces competence. Understand this. The performance trap is killing your potential. Every minute you spend crafting the perfect LinkedIn post about your coding journey is a minute you're not coding. Every dopamine hit you get from 50 likes is training your brain to seek validation instead of seeking mastery. And worse, far worse, is what happens when you inevitably hit a wall. Because you will hit a wall. You'll encounter a concept that doesn't make sense, a bug you can't solve, a project that's harder than you thought, a week where you don't make visible progress. And if you've been performing your journey publicly, you now have an audience watching you struggle. And your brain, your ancient validation-seeking brain, will start making decisions based on that audience. You'll skip the hard problem, because it's taking too long and you haven't posted an update in 3 days. You'll pivot to something easier that you can post about. You'll start another tutorial because at least you can post screenshots of completing modules. You'll optimize for content instead of competence. And 6 months later, you'll have a feed full of day 180 of coding, posts, and a portfolio full of nothing. AC3, the transformation. So here's your choice. You can keep performing, keep posting, keep optimizing for external validation and dopamine hits from people who aren't hiring managers and can't debug your code. Or you can go dark, completely dark, and build something real. The Silent Build Protocol. For the next 90 days, you will implement complete strategic silence around your learning journey. Phase 1. The Social Media Funeral. Days 1 to 7. Announce nothing. No starting my journey posts. No day X of 100 days of code. Updates. No code snippet screenshots. No just deployed my first app. Celebrations. No LinkedIn skill endorsement requests. Nothing. Delete the performance triggers. Turn off notifications for likes and comments on old posts. Remove coding-related hashtags from your bio. Leave accountability groups where people just post about posting. Unfollow accounts that make you feel like you need to perform. The replacement ritual. Every time you want to post about what you're learning, write it in a private journal instead. Document for yourself, not for an audience. Ask yourself, am I writing this to remember it or to be seen remembering it? Phase 2. The deep work immersion. Days 8 to 60. The project selection. Pick one substantial project. Not a tutorial, not a course, a real application. Something that scares you slightly, something you're not sure you can build. For back-end devs, a complete REST API. With authentication, authorization, database relationships, caching, and deployment. For front-end devs, a full application with state management, API integration, error handling, responsive design, and production build. For full-stack devs, both integrated, deployed, with CI/CD pipeline. The silence rules. Build it completely in private. When you get stuck, and you will, Google it, read docs, ask on Stack Overflow with a throwaway account if needed. But never post progress updates. Never share code snippets for validation. Never fish for encouragement. The learning log. Every day, write down 3 things. What you built today. Specifics. Implemented JWT, refresh token rotation with Redis catching. What you struggled with. Spent 2 hours debugging CORS issues with credentials. What you understand now that you didn't this morning. CORS pre-flight requests require specific headers for cookies. This log is for you, not for your followers, not for your personal brand, for you. Phase 3. The revelation. Days 61 to 90. Finish the project. Make it work. Not perfect, not viral worthy, just functional. Deploy it. Make it live. Real URL. Real users can access it. Write actual documentation. README that explains what it does and how to run it. The silent audit. Review your learning log from 90 days. Count how many real, functional features you built. Compare to the previous 90 days when you were performing publicly. The difference will be undeniable. The strategic reveal. Now, only now, you can show people. But you don't announce the journey. You announce the destination. You don't say, I've been learning React for 90 days. You say, I built this, and you show them the live application. Let your work announce your arrival. Let me tell you what happens when you master this. 6 months from now, someone will ask you, how did you get so good so fast? And you won't know how to answer, because from your perspective, you weren't fast. You were just consistent. You were just focused. You were just building while everyone else was performing. But from their perspective, you appeared out of nowhere. One day you were a beginner, and the next day you're showing them production-ready applications. They'll think you're talented. They'll think you had some advantage. They'll think it came easy to you. They don't know about the silent nights, the bugs that took hours, the features you rebuilt 9 times, the documentation you read until 2 a.m., The Stack Overflow answers you studied like scripture. They just see the result, and the result speaks louder than any day 180 of coding. Post ever could. Here's the paradox, and pay attention because this is critical. When you stop performing your learning, people take your competence more seriously. The developer who posts every day about learning React seems like someone who's trying to learn React. The developer who shows up with a deployed React application is someone who knows React. Talk is cheap, proof is priceless. But here's the warning. When you start building real things in silence, people will get suspicious. They'll ask, "Why so quiet? What are you working on? Why aren't you sharing your journey?" And you'll be tempted to break the silence, tempted to show them the half-finished project, tempted to explain the complexity of what you're building. Resist. Because the moment you start explaining, you start performing. And the moment you start performing, you stop building. The fortress is built in private. The reveal happens once, and it happens with evidence, not explanations. The challenge, right now, today. Before you listen to another chapter, delete your last 3 learning journey posts. All of them. Commit to 90 days of complete silence about what you're building. Pick your project. Start building it. Tell no one. Document everything privately. Share nothing publicly. And in 90 days, when it's done, when it's live, when it's real, then you can show them. This is the 6th wall of your fortress. The ability to build in darkness while everyone else performs in light. The ability to let your work speak so your words don't have to. You've learned the power of silence. You understand now that broadcasting drains energy and performing delays progress. You know that the fortress is built in private and revealed only when complete. But here's what you don't know yet. What happens when you're building in silence, when you've eliminated comparison, when you've rejected the talent myth, when you've mastered emotional control, when you've weaponized failure, when you've built unshakable discipline, and you still fail? What happens when you do everything right and the code still breaks? When you apply to 50 jobs and get 0 responses? When you build 3 projects and no one hires you? What happens when the fortress stands strong, but the world outside doesn't seem to notice or care? That's when you need the darkest lesson of all. Chapter 7. How to Debug Your Own Mind. It's 2 a.m. and you're still awake. Not because you're coding, not because you're debugging. You're lying in bed, staring at the ceiling, running the same recursive loop in your head that you've run 1,000 times before. I'm not smart enough for this. I should have figured that out faster. Everyone else understands this better than me. Maybe I'm just not cut out to be a developer. Maybe I should quit before I waste more time. The same thoughts, over and over, like an infinite loop with no break condition. And every iteration makes the anxiety worse, the doubt deeper, the exit condition more impossible to reach. You think these thoughts are giving you information. You think they're helping you evaluate your situation objectively. You think this mental runtime is productive processing. It's not. It's a bug, a critical bug. And it's been running in production in your mind for so long that you think it's a feature. Here's what you need to understand. Your thoughts are code you can refactor. When your internal dialogue says, "I'll never understand recursion," that's not a truth statement being evaluated. That's a hard-coded bug. a destructive pattern. Mental malware that's been deployed in your cognitive system and you've never bothered to debug it. And just like bad code in your application will crash your program, bad code in your mind will crash your progress. The difference is this: you know how to debug your code. You set breakpoints, you examine variables, you trace execution, you identify the bug, isolate it, fix it, test it, deploy the fix. But you've never learned to debug your mind, so you let the same broken thoughts execute over and over, producing the same catastrophic outputs, wondering why your mental application keeps crashing. Listen closely. The fortress gives you the tools to catch these destructive thought patterns, challenge them with evidence, and rewrite them into something functional. This is not positive thinking. This is not affirmations. This is not pretending the bugs don't exist. This is cognitive debugging, systematic, technical, ruthless. And by the time you finish this chapter, you'll have a protocol for identifying mental bugs, isolating them, testing them against reality, and deprecating the ones that fail every test. Let me show you exactly how mental bugs operate. There's a developer named Kevin, mid-20s, technically competent, can write clean code when he's calm. But Kevin has a critical bug in his mental runtime: panic loops. Kevin gets invited to a technical interview, leet code style. Live coding. 30 minutes to solve a medium difficulty problem. The interviewer shares the screen. Kevin reads the problem, and immediately the panic loop executes. I don't know this one. I should know this one. Everyone else would know this one. They're going to think I'm incompetent. I'm going to fail. I'm going to fail. I'm going to fail. The loop runs. Kevin's working memory, which should be processing the problem, is now consumed by the panic thread. His cognitive resources are maxed out managing anxiety instead of solving algorithms. He freezes. He stammers. He writes a brute force solution that times out. The interview ends badly. Here's what Kevin doesn't understand. The problem wasn't the coding challenge. The problem was the mental runtime error that consumed his processing power. The algorithm was solvable. Kevin has solved similar problems before, but his mental application crashed before he could even attempt the logic. There's another developer named Lisa. Same skill level as Kevin, same interview scenario, same algorithmic challenge. Lisa reads the problem, and the panic subroutine tries to execute, I don't know this one. But Lisa has implemented a circuit breaker. The moment the panic pattern is detected, it triggers the stop protocol. Stop. Lisa literally stops moving, stops reading, stops thinking. Take a breath, deliberate, controlled. 5 seconds in, 5 seconds out. Observe. She asks herself, what's actually happening? I'm in an interview. I was given a problem. I don't immediately see the solution. That's normal. That's not failure. That's the starting condition of every coding problem I've ever solved. Proceed. Now, with her working memory not consumed by panic, she reads the problem again. She identifies it's a two-pointer problem. She's seen this pattern. She writes the solution. It passes all test cases. Same interview, same problem. Two completely different mental execution paths. Pay attention to this. The difference between Kevin and Lisa isn't intelligence, it's mental debugging capability. Kevin is running unpatched legacy code in his mind, destructive thought patterns he's never examined, never tested, never refactored. Lisa has implemented cognitive unit tests. She's identified the patterns that crash her mental application, and she's written exception handlers for them. Here's the truth no one tells you. Your negative beliefs are untested assumptions that have been running in production for years. You believe, I'm not smart enough for this. But have you tested that belief? Have you written unit tests for it? Have you checked it against actual evidence? No. You just accepted it as truth and let it execute every single day, affecting every decision, sabotaging every opportunity. It's time to debug your mind like you debug your code. So here's your choice. You can keep running mental malware. You can keep letting destructive thought patterns execute unchecked. You can keep crashing during interviews, code reviews, and learning sessions because your internal runtime is riddled with bugs. Or you can implement a mental debugging protocol. For the next 30 days, you will systematically identify, test, and refactor your destructive thought patterns. Phase 1. Pattern recognition, days 1 to 10. The thought logger. Carry a small notebook or use a notes app. Every time you notice a negative thought about your coding ability, log it immediately. Format, timestamp, trigger, exact thought. Example, 2:34 p.m. Failed to solve LeetCode problem. I'm too stupid for algorithms. Common patterns to watch for. Absolutist thinking. I'll never understand this. Comparison loops. Everyone else gets this faster. Fortune telling. I'm going to fail the interview. Mind reading. They think I'm incompetent. Catastrophizing. This means I'll never be a developer. The frequency analysis. After 10 days, review your logs. Identify the top 3 most frequent patterns. These are your critical bugs, the ones consuming the most mental resources. Phase 2. Unit testing. Negative beliefs, days 11 to 20. Now you'll test each negative belief like you'd test a function that's producing wrong outputs. The evidence-based unit test. Pick your most frequent negative thought. Let's say it's, I'm not smart enough to be a developer. Test 1. Historical evidence check. List 5 technical problems you've solved in the past month. If you've solved problems, the belief, I'm not smart enough, fails this test. Test 2. Comparison validity check. Are you comparing your Chapter 3 to someone else's Chapter 20? If yes, the comparison is invalid data. You're comparing incompatible versions. Test 3. Scope analysis. Does not understanding async/await yet actually mean not smart enough for all of development? If the belief generalizes one skill gap to total incompetence, it fails the scope test. Test 4. Counterexample search. Find one piece of evidence that contradicts the belief. Example, I debugged that CORS issue last week that took 3 hours. If even one counterexample exists, the absolute belief, I'm not smart enough, is false. The test results. If a belief fails 3 out of 4 tests, it's a bug, not a truth. Tag it as depreciated in your mental code base. Stop executing it. Phase 3. The stop method implementation, days 21 to 30. This is your runtime exception handler. Deploy it every time a panic loop tries to execute. The stop protocol. S. Stop. The moment you feel panic, anxiety, or imposter syndrome starting, literally stop what you're doing. Don't try to push through. Don't try to think positive. Just stop. T. take a breath. 5 seconds in through your nose. 5 seconds out through your mouth. This is not woo-woo. This is resetting your nervous system. Your amygdala was hijacking your prefrontal cortex. Deliberate breathing forces executive function back online. O. Observe. Ask, what's actually happening right now? Not what you fear will happen, not what happened before. What is actually, objectively, happening in this moment? Example, I'm in a coding interview. I was asked a question. I don't immediately know the answer. That's the current state. P. Proceed. Now, with your working memory not consumed by panic, proceed with logic. Break down the problem. Identify what you know. Identify what you need to find out. Execute the solution. The practice scenarios. Use the stop method in these situations, before every coding interview, during every code review where you feel defensive, when you're stuck on a bug for more than 30 minutes, when you see someone else's code and feel inadequate, when your PR gets rejected with critical comments. Phase 4. Mental refactoring. Ongoing. Rewrite destructive patterns into functional ones. Old code. I'll never understand this. Refactored. I don't understand this yet. What's the next smallest piece I can learn? Old code. I'm too stupid for algorithms. Refactored. Algorithms are hard for everyone initially. What pattern am I missing? Old code. Everyone else is better than me. Refactored. I'm comparing different stages of development. What can I learn from their approach? Old code. I'm going to fail this interview. Refactored. I don't know the outcome yet. I'll solve what I can and learn from what I can't. The refactoring rule. Keep the observation. The situation is hard. Remove the catastrophizing. Therefore, I'm doomed. Add the next action. Here's what I can do. Let me tell you what happens when you master this. 6 months from now, you'll be in a high-pressure technical interview, the kind that used to make your hands shake and your mind go blank. The interviewer will give you a problem you've never seen before, and the panic subroutine will try to execute, but you'll catch it. Instantly. You'll notice the thought, I don't know this one. And instead of letting it spiral into, I'm going to fail, you'll just observe it, acknowledge it, and let it pass. You'll proceed with logic. Break down the problem. Identify the pattern. Write the solution. And while the other candidate with better technical skills is frozen in panic, you'll be calmly explaining your approach. Here's the paradox. The developers who seem naturally calm under pressure aren't calm. They're just debugged. They still feel the panic. They still have the negative thoughts. But they've implemented exception handlers. They've tested their beliefs. They've refactored their mental code. The panic tries to execute. The handler catches it. The program continues. But here's the warning. Mental debugging is not a one-time fix. Your mind will try to reintroduce old patterns. Stress will try to reinstate depreciated beliefs. Failure will attempt to restore catastrophic thinking. You have to maintain your mental code base. Run your unit tests regularly. Catch the bugs before they hit production. This is not optional. This is the maintenance cost of a high-functioning mind. The challenge. Right now, today, before you listen to another chapter, write down your most frequent negative thought about your coding ability. Run it through the 4 unit tests. Does it pass? Or is it a bug you've been running in production for years? If it fails the tests, tag it deprecated and write the refactored version. Tomorrow, implement the stop method once. Just once. The next time, panic starts. This is the seventh wall of your fortress, the ability to debug your own mind with the same rigor you debug your code, the ability to catch mental bugs before they crash your progress. You've learned to debug your mind. You understand now that destructive thoughts are code you can refactor, that panic is a runtime error you can handle, that negative beliefs are untested assumptions you can invalidate with evidence. But here's what you haven't faced yet. Everything you've built, the talent rejection, the emotional firewall, the comparison blackout, the failure weaponization, the discipline system, the silent building, the mental debugging. All of it requires one thing most people will never have: resilience. Not the kind of resilience that sounds good in motivational posts. Real resilience. The kind that lets you get rejected 50 times and apply for the 51st job. The kind that lets you fail a technical interview and schedule another one the next day. The kind that lets you build for months with no visible progress and keep building anyway. And resilience isn't something you're born with. It's something you build through controlled exposure to failure, through deliberate stress testing, through strategic hardening. Let's build it.